All right, this is Honors Algebra 2 Pre-Calculus. We're doing 8.4 in Algebra 2, which is adding and subtracting rational expressions, and this is our first video in the series. So, as we've done in previous sections, we're going to start first with a few problems with numbers so that we can review the logic and mathematical reasoning of how we add and subtract fractions, and then we'll apply those same skills to problems with variables, right? So realistically, I know it's stressful when we put letters in your math, but variables behave just like numbers, and if we can remember that, then it's a little bit less stressful. So, recall that in order to add or subtract two or more fractions, you need to get a common denominator. So sometimes we already have a common denominator like this, right? So 4/3 plus 8/3. Hey, they already have a 3 as the common denominator. Great. So we can just add the numerator and get 12/3, which is 4/1 or just 4. So note that 12/3 is not wrong, but in this class, I'm generally going to ask you to simplify if possible. So the answer I would want is 4/1 or 4. As we move forward in math and you get higher up and into AP Calculus and beyond, you'll be asked to simplify less and less, and most of your simplification will be selfish, right? You'll simplify because you need to simplify. But for here, I want you to get the practice simplifying, so I'm going to ask that you give me the answer either 4/1 or 4. Now, if we don't already have a common denominator, one way to get the common denominator is by simply multiplying each denominator by the other denominator. So, for instance, 1/2 plus 5/3, I have a 2 denominator and a 3 denominator. The easiest common denominator would be the least common multiple, which would just be 2 times 3, right? So I'd multiply the 1/2 by 3/3, I'd multiply the 5/3 by 2/2, I'd get 3/6 plus 10/6 is 13/6, and that would be my answer. So rational functions go the exact same way. So we're going to walk through some examples with rational functions. So in this example, right, in E1, I have an A and a B. And in both A and B, I want you to notice that I already have a common denominator, right? So the denominator in A is x plus 3. Since the denominators are the same, I can just combine the top into a single expression and keep the common denominator, and that's my answer. Done. If we do the same thing for B, right, again, common denominator. So I can just go ahead and combine the top. So I get that this is an x squared minus 9 over an x minus 3. Now, while that answer is not wrong, it's not fully simplified, right? Because when I see x squared minus 9, I think, oh, hey, that's a difference of squares. That's an x plus 3, x minus 3. So I can actually cancel this, and my answer is an x plus 3. So that's sort of akin to going back to this problem right here, where I put them together, and at first nothing canceled, but when I put them together, there was a factor that I was able to cancel. The 12 divided by 3 both have a factor of 3, so I was able to cancel the 3, right? Same idea here, okay? So again, just notice that that was a difference of squares, right? All right, so I'm going to give you a P1 to try. Same idea, you'll notice that you already have a common denominator, so feel free to pause me. I'm going to go ahead and walk through this. So I already have a common denominator, right? So I'm adding 3x minus 1 plus this whole 5 plus 2x. I put it in parentheses because had this been a minus, I would have to be very careful that it goes to both of these terms. It's a plus, so it doesn't really matter. But if it had been a minus, I'd have to be really careful that it goes to both terms. So I have a plus 5 and a plus 2x. When I combine my like terms, I get a 5x plus 4 over 2x minus 1, and that's the best I can do, right? When we combine this one, right, so put a little line there, they already have the common denominator, so I just have to combine them. It's a 2x minus 10 over an x minus 5, and while that answer is not wrong, it's not fully simplified because there is a GCF on top, and if I factor that GCF out, I'm able to cancel these, and my final answer is just a 2 or a 2/1 if you felt more comfortable. That's the same answer. All right, so that E1 and P1 were similar to this first example where I already had a common denominator, right? So now let's go ahead and deal with what happens when we don't have a common denominator. So in E2, now my denominators are different, right? X minus 1 and x minus 5 are different denominators. So what I'm going to need to do is I'm going to need to take this denominator, and I'm going to multiply this fraction by that denominator over itself. I'm going to take this denominator, and I'm going to multiply the other fraction by that denominator over itself. Kind of ran out of room. So, all right, so what that means is that I get a common denominator of an x minus 1 times an x minus 5. It doesn't matter what order you write them in. And on top, I'm going to get a 3x minus 15, so 3x minus 15, and a 6x minus 6, so plus 6x minus 6. So then when I put my like terms together, I get a 3x plus a 6x, which is a 9x. I get a minus 21. And I get an x minus 1, x minus 5. And that answer is totally fine. So this answer is great, okay? So this is fine. You can stop there. Other possible answers, if you wanted to look, you could take, I didn't mean to take a 9, you could take a GCF of 3 out if you want, because there is a 3 on the top. I don't think there's any reason to do it per se, but you could, right? You could take a 3 out and have a 3x minus 7. You see that that's not a factor on the bottom, but that answer's also okay, right? So this is also okay. Again, I would probably have stopped here, right? This is where I would have stopped. It's the easiest answer. If you really wanted to, you could also FOIL everything out on the bottom. I don't know why you would, but you could, right? So you could make this an x squared. Outer is a minus 5x and inner is a minus x. That's a minus 6x plus 5. So this is also okay. But again, if it were me, I would stop here, right? Okay, so the trick part with this second one, notice that that's subtraction. So I'm going to do the same thing with getting a common denominator. I'm going to say, oh, this x minus 3 needs to be multiplied by both of these, right, to get a common denominator. And this x plus 1 needs to get multiplied by this thing. So what's going to happen is I'm going to get that the denominator is an x plus 1 times an x minus 3. Right? I don't need to write it twice. I just write it once, right, because that's how common denominators work. The 4 times the x plus 1 will give me a 4x plus 4. And then this is a negative 5x that's getting distributed to these. So I'll get a negative 5x squared plus a 15x. When I clean this up, I'm going to get negative 5x squared plus 19x plus 4. And you could certainly check and see if this is going to factor, but here's my argument. It's not, I can check and see if it factors into either of the things on the bottom, but the only reason that there would be any incentive to factor the top is if either x plus 1 or x minus 3 was a factor. I already know that x minus 3 is not a factor because 3 is not a factor of 4. X plus 1 could work, and I could check and see if it factors, but the only incentive to factor this. So it's only useful to factor if the x plus 1 or the x minus 3 cancels. Otherwise, there's just no reason to put the work in, right? So I could check really quick. I could see if they cancel. In fact, the easiest way to check, if we do a little bit of a callback to the last chapter, the easiest way to check would be to do synthetic division and see if that negative 1 goes in here. It doesn't. You're going to see that pretty quickly. So that's a no. And I can already tell you that 3 doesn't because it's not a factor of 4, but you could check the same way. So, so it's not going to work. So that would be the answer I'd go with. If you really wanted to clean it up at all, you could FOIL the bottom, but really I don't think there's any incentive to do it. If you wanted to FOIL the bottom, you'd get x squared minus a 2x minus a 3, right? And that's okay too, but I would stop here, all right? Okay, so go ahead and try a P2, same idea, right? You can pause me if you want. So I need to multiply this denominator by this fraction. Because again, they're factors that have nothing in common, right? X plus 2 and x minus 4 are completely different factors. They have nothing in common. So what's going to happen is my denominator is going to be this x minus 4 times an x plus 2. The numerator is going to be an x times the x and the negative 4, so it's an x squared minus 4x. And it's going to be this positive 8 times both the x and the plus 2, so plus 8x plus 16. So my answer is x squared plus 4x plus 16 over an x minus 4 times an x plus 2. And again, the only incentive to factor this is if I think, I can cancel either the x minus 4 or the x plus 2, and I won't be able to. The easy hint that I won't be able to is that I need numbers that multiply to 16 and add to positive 4. They have to have the same sign. That's mathematically impossible, right? Like 1 and 16 add to 17, 2 and 8 add to 10, 4 and 4 add to 8. There's no way. So the top is prime. So that's great. I would stop here. If you really wanted to FOIL it out, you could. You'd get x squared plus 4x plus 16 on the top, and you'd get an x squared minus a 2x minus an 8 on the bottom. And that's fine too, right? But again, I'd stop here. This one's also okay. Okay, for the last one, be careful that factors, right? So factors are about multiplication is the way I'm trying to phrase this. So you can't just like add a plus 7 to the top and bottom of this fraction. That doesn't work. This is a factor and x is a different factor. You're going to have to multiply this fraction by the x plus 7. You're going to have to multiply the other fraction by the x over x, right? So what's going to happen is I'm going to get a common denominator on the bottom of an x times an x plus 7. On the top, I'll get a 2x and then this is a negative 3 that gets distributed. So negative 3x minus 21. So I'm going to get that this is a negative x minus 21 on top and an x times an x plus 7 on the bottom. And that's about as good as it gets. If you want to FOIL out the bottom, you certainly could, or distribute out the bottom. You definitely could make this an x squared plus 7x, but I don't know why there would be an incentive to do that. So that's also okay. All right. And I think that might be it for this first video.